Welcome. Today we're going to talk about how to write an equation of a circle. And you'll do more of this when you get to pre-calculus, when you in a couple of years. But in the meanwhile, we're going to just touch on it so that you have some familiarity with it. There are two equations that we can use to help us write, two formulas that help us write equations of circles. The first one is pretty simplistic, and this one is the equation that represents a circle that has a center at the origin and a radius of r. And this equation is x squared plus y squared equals r squared, where x and y represent any 2 points, or x and y represent the x and y coordinate of any point that lives on the circle itself. And the circle has, like I said, an center at the origin. So just some simple things to start off with. I'm going to just save the exciting part for later. One thing I noticed that a lot of my students try to do is when they get to writing equations of circles, they try to find numbers to put in for x and y. But folks, all equations for circles have an x and they have a y as variables. The x and y in our equation will always be variables. So you're never going to replace the x and y with numbers. They are just always variables. So if I look at this circle, the first thing I want to do is identify that the center is at the origin, because that's what allows me to use this equation. The next thing I notice is that it has a radius of 2. See, very exciting. It has a radius of 2, a center at 0, 0. Therefore, I can substitute the radius into my equation. Remember, x and y are always going to be x and y. The only thing I can really do to simplify this equation is to square my radius. And so the equation for this particular circle would be x squared plus y squared equals 4. It's just that easy. But it's not always that easy, is it? So sometimes your circle has been translated and is no longer centered at the origin. And for circles like that, we have a more interesting and a more complicated formula. For circles that have a center somewhere other than the origin, we have to do the transformation of that origin. And we do that by looking at this formula. This formula says I take the x value, the x minus whatever my horizontal transformation is, squared, plus the y minus the vertical transformation, squared, equals my radius squared. The horizontal and the vertical transformation for any circle is represented by the new center ordered pair. And you could use this for any circle, even one that has a center at the origin. It's just that at the origin, the center is 0, 0, so those values fall off. All right, so again, remember, x and y are always variables. We use numbers for h, k, and r. This example asks us to do a little thinking. Okay, example 2 tells us that there is a point, -3, 4. It's on the circle, and the circle's center is at -1 and 2. So for this, I need to identify, oh, it even gives me a picture, isn't that lovely? I need to do a couple of things. I need to identify that h is my center, and I marked this incorrectly. My h is going to be the x value of my center. I know that that's an h because the h follows the x, and so it uses the x coordinate. So in this case, my x value should be -1. And then in this one, I look for my k value. My k value follows the y variable, so I use the y coordinate, and that in this case is 2. So I know this value, and I know my h value was a -1. I'm going to protect him just for a moment. You'll see why in a moment. And then I need to find my radius. And in this case, I wasn't actually given the radius, but there are a couple of things I can do to find the radius. I could use Pythagorean theorem and create a right triangle because it's on a coordinate grid. I could use the distance formula because I have 2 ordered pairs. So I could do the x value, the difference of the x value squared plus the difference of the y value squared, and then take the square root. Or I could also use a little trick here. I could recognize, because these points are very squarely at the crosshairs of the coordinate grid, I could say that this side, the side of this triangle is 2, the side of this triangle is 2, and that means I have an isosceles right triangle. And we know that in an isosceles right triangle, the two sides being equal have a relationship to the hypotenuse that is x square root 2. So I think it would be safe for me to say that the radius of this circle is 2 square root 2. You won't always be able to use your 30, 60, 90, or 545 special right triangles to determine the length of the radius, but you can in this case, and we'll do some other examples where we use Pythagorean theorem or distance formula. For the moment though, we now have all of the components that we need in order to write an equation. So remember, I always have an x and I'm subtracting. I always subtract. And I add to that the difference of y minus my k value squared. And that will be equal to my radius squared. So a couple of things to be careful of here. When I'm subtracting negative, that becomes a positive. I can't simplify this anymore. That's going to stay y minus 2 squared, but I can simplify 2 square root 2 squared. Remember that you square both the whole number and the radical. The square root of 2 times the square root of 2, square root of 4, square root of 4 is 2. So my final equation, still maintaining my variables and y, would look something like this. And that is an equation that can be used to find any ordered pair on that circle. All right, I promised this was a little bit more complex. I'm not going to show you the whole of example 4 because everything you need is already given to you. There's not a lot of complexity here. It's just an exercise in substitution. I always start with my formula. I need to identify the h value of the center, the k value of the center, and my radius. And in this particular problem, I was given all of those numbers. So my h value in this case is -3. I can substitute that in. I protect him. I identify my k value, -5. I substitute him. I protect him because he's negative. And then my radius is 6.1. I can substitute that into my formula. And then I square. I rewrite. And I simplify. You should come up with something that looks like x plus 3, subtracting a negative is positive, plus y plus 5 equals, and this comes out to 37.21. I said I wasn't going to do it, but look, I did it. Example 5. What was I given in example 5? Well, the first thing I notice is I actually have my equation written over here. I have prepared to identify my h, k, and r. And I actually have prepared because they did not give me the radius of this circle. And again, I have misidentified these. Those aren't there. The h of my center follows the x in my formula. Therefore, I use the x coordinate. It's a 3. My value follows the y, therefore I use the y coordinate, which is -3. I'm going to protect him because he's negative. And I can go ahead and fill in the rest of my equation here. But I'm stuck. I do not know the radius. So to find the radius in this particular example, I'm going to have to substitute in to the distance formula my 2 ordered pairs. And it does not matter whether I use the point as the initial x or if I use the center. It makes no difference whatsoever. I'm going to substitute in -1 minus 3 squared plus 2 minus -3. And when you simplify that lovely little thing, you end up with the square root of 41. I'll let you do that algebra. So now my radius is the square root of 41. I can substitute that in. I have to remember that I'm going to square my radius, which actually is really nice because the square root and the square functions are inverses. They undo each other. And so this simplifies to just plain 41, and the rest I just rewrite. I can simplify this a tad. Subtracting a negative is the same as adding a positive, and that's my equation that could be used to represent a circle with a center of 3, -3, and a point on that circle of -1, 2. Okay, last one, and then we'll be done with equations for today. This last one's actually asking me to graph the circle. So I need to identify the center, and I need to figure out how long, or what the radius is, what the length of the radius is. So the first thing I'm going to do is look at the equation I was given. Notice it has an x and a y because we always have x and y's. This, the 2, represents the x coordinate of my center. But the thing I notice here is that I've subtracted. So I had x minus something, and when simplified, that gave me a positive 2. To get a positive here, I had to subtract negatives, so my h value for my center is -2. In algebra, we often refer to this as insider's lie. I don't know if you remember that, but you will hear it next year. For the k value of my center, or the y value of my center, I look at the second part of my equation. I notice that all my equations are y minus, so if I just cover that up, I have the k value given to me. It's a 1. So that helps me identify the center of my circle. I'm going to go ahead and plot that. I'm going to go over 2 and up 1 and identify that as the center of my circle. The only thing I'm missing now is my radius. And if you remember in the equation, it's radius squared. So I know that radius squared is equal to 9. I take the square root of both sides, and I end up with a radius of 3. That means that from my center, I move 3 units, and I usually just go in the cardinal directions to get at least 4 points that could be used to comprise my circle. And from here, guys, it's going to be a sketch, and your sketch hopefully will be better than mine. I'm not so good at sketching circles, but it's going to look something like that. And there we have an example of taking an equation of a circle, identifying the center and the radius, and then actually graphing it. That's it for today. Thanks for listening, and we'll talk to you again soon.